So we'll first have Leander Conradie. He is a front-end developer in Germany, and we'll talk about time to think about time. Enjoy his talk. Thank you very much.
No, it's not okay. Yeah, it's okay. So, question. Who of you have ever seen this? Not a 5.5-inch version, 8-inch version. This is not a 5.5-inch. This is not a movie prop. This is a real thing. It contains 1 megabyte of data. It was damn expensive in the old times. Cost a lot of money. I used to work with these things. My first job was to generate a modification to a boot sector on one of these things to make an Apple II boot. And that disk still contains a program I wrote. It dates from 1982. So I have been in the business for a while. But I was small then. Currently I'm working in Freiburg as front-end. And not all front-end, believe it or not, is web-based. Some of the projects I work use touchscreens for industrial control, and the programs are written in Java and steers machines, which can actually kill people. So I have to deal with actual safety problems too. And the other half of the time, I often work on a conference management system, which is web-based in Ruby on Rails. Today, my talk is called Time to Think About Time. And we will look at how you can incorporate the history of objects and user interactions into a user interface to improve the user experience. Why are we here? What are we doing? Why does half of us sit in an office with a machine with a keyboard and type on it all day and play with a little thing called a mouse, which is only a vague similarity to a mouse? Why are we doing this? Why do we have machines? Why do we have tools? We do this for only one reason, only one purpose: to help us perform tasks more efficiently. It's all about efficiency. You don't have to do things with a computer. The accountant can also do her sums on a piece of paper with a pencil. They moan about the computers, trust me, but if I tell them I'll take away the laptop and give them back their piece of paper, they, well, no, well, it's okay. Excel is fine. We can solve the problem. Add that. And this talk is about moving towards that goal. We will examine how the history of what a user is doing and the history of the object he is manipulating can be brought into a user interface to bring him closer to his goal of working more efficiently. Now, the world around us, the things that we model on a computer, consists of particles. And in physics, all things in a particle is measured with a position, just a place. Things are static. But this is not enough. When you only measure the position of something, the state of something as it is now, there is no concept of change. There is no concept of time. In the real world, things have a momentum. They move. Isaac Newton said in the 17th century that objects stay in motion unless a force is applied to them. The basic state of things are not static. The basic state is always movement. Things by nature tend to move. Einstein said that the speed of light, the movement of something, is the measurement reference point of space-time. The base case is movement. Everything around us changes all the time. Nothing stays the same. Things move and they go on from one point to another and they change and they evolve. And movement is the change of state over time. This is what it's called. It's also called momentum. Every object that we deal with on a day-to-day basis, if it's a digital object or real objects, has a process that preceded it, that causes it to be the way it is now. And this brings me, I will have 10 take-home points, and I will repeat them at the end of the talk, which is the things I want you to remember from this talk. Take-home point number 1, the universe consists of processes, not of things. Even if you go into deep physics nowadays, processes is the game. Things not the game anymore. What's that got to do with us? This is a physics lecture. This is a front end. That's okay. We're still at a front end conference. I'll keep Einstein out of it for the rest. What has it got to do with front end design? What has it got to do with user interfaces? A user interface of a computer interfaces a user with a software artifact, which is a digital representation of an object in the real world. And as the real world behaves, which we've seen is motion, so should the software artifact behave. But the history of the objects that we manipulate and the objects that we represent is often missing from software. Often we see things in a frozen moment of time. When I open an editor, a database with a record of somebody, say a conference attendee, I see him or her as she is now. I see the registration as it is now. Seldomly in a program do you see the registration as a process that brought it up to the point as it is now. And the point is, this is sometimes useful. Sometimes it solves problems. And it makes the user's life easier, the user of the software. The external objects have a narrative, a story, a history behind them. If you go look at the last few front-end conferences and several other conferences in front-end design, user interface design, you'll see that the concept of a narrative, of a story, is a very up-and-coming topic at the moment. There's another talk this afternoon about this, here in fact. The processes that follow created the objects that we're working with are often neglected, and allowing the user to see them and perhaps manipulate the history can improve the user experience. This is the first thing we will look at. Secondly, when using a software system, a user performs a sequence of tasks. Often, the software does not represent options to the user based on what he has done before. The history is simply forgotten. And it's a shame because it's useful. And we will see how you can incorporate that movement of the user, the flow, in a user interface to improve his experience. Take-home point number 2. User actions and software objects are the results of a process. There's always something that came before. We're going to look at 2 things. The first is allowing the users to examine the objects, the history of the objects they're working with, and using the history of their actions to improve their flow. Would we be interested in object history? Why would this improve our experience? Now, the first reason is nostalgia. Now, a guy who's significantly more handsome than me said it better. Nostalgia is something that triggers emotions in people. We do go back in time and look at photographs of our children, of trips, of holidays. But this is not necessarily useful in a business setting because it leads to old junk. There's a gap hole there where you keep files. Who of you still have files around that dates from 5 years ago, 10 years ago? Somewhere on a floppy, on a CD? Come on, be honest, hands up. Yeah, exactly. Do you actually look at them? Nah. But it's nostalgic. You like to keep them. It makes you feel happy, and it makes you feel unhappy if they're gone. It's like something is missing. But like we said, it's not useful in a business sense. But sometimes looking at old objects can trigger memories and trigger ideas of how we can improve the future. Now, the user sees an object, and the object has been changed by a sequence of events before it. But what the user is usually interested is not the events. It's not interested in actions. It is interested in why. Very often, if we want to go back in history and go back in time to look at things, we are interested not in how things were. We are interested in why they are as they are now. This is an important distinction to make in a user interface because one of the most important principles in UI design is to model the user's mental map onto the software and not the programmer's mental map. What we really want to see when we go back in history is the causality, the sequence of events of why we are now there. Causality is, however, different to represent. We cannot represent reasons in the sense of this user changed the object because of that reason and this. We can only represent the events. But ultimately what the user wants to know is how the events flowed together to cause a result. Point number 3. Looking at object history is not necessarily about a set of construction steps. It is about why things became the way they are now. Why is it interesting to look at the action of a user as opposed to the history of an object that is manipulating? In user interface, there is a concept called flow. Flow is a very desirable property. This is when the user actions run one after the other smoothly, and the software guides you in your task, and everything just runs automatically. Each of you have done that. Sometimes the software, you have to click again and go there, and click again and go there. It's much more useful if the software just anticipates what you're doing and helps you. It's not just software systems. Cars are like that if you drive them. If flow is missing from a system, it is like you have a sequence of stumbling blocks and you fall around all the time and you don't quite get there. It's a very important property to maintain. Users should feel like they have to follow or worse, memorize a strict set of instructions to achieve their goal. Instead, what you want is a feeling of naturalness and inevitability of flow. This comes from a book called Micro Interactions, which is a very good book to read for anybody interested in front-end design, by the way. We can use the history of what the user was doing just before to improve the flow. Take-home point number 4. Flow is good. Flow is about keeping momentum. Now, if we have a software system and we want the user to be able to manipulate the history or see the history or view the history, what should we be able to do? First of all, the software should remember everything. It shouldn't just remember the system of the database as it is now. It should remember the steps as it came before. This will allow the user to reconstruct the system as it was. It will allow the user to manage the history. You would be able to set specific points in time and say, this is the time. We all know this from software version control. Software is released, Microsoft Windows came out as version 3.1. There was a specific decision by some program manager to commit a version in time and give it a name. Then came out NT4, and then Windows Vista, and then Windows 7. Specific committed versions. You need to have a history of the development to be able to do that. Secondly, you sometimes would want to create alternative histories. You have one version, you branch off. We know this from version control systems. This is an alternate history, an alternate flow of time. Time is not necessarily linear. And this brings me to take-home point number 5. The database state, as it's now, is really just a cached version of the event log up to now. Now, in a UI, how can we represent history? Time adds another dimension to a system. We have a 2-dimensional screen, and we want to represent objects on it. And if we have to add time, we have to add another dimension which goes into the screen. And there are several ways of dealing with this. The first is we can just display the events as they were in the past, or we can display the objects as they were then. The classic way of doing this, which all systems somewhat implement, is a log file. We all know that. The problem is a log file is something that's inside the computer. And usually you have to go to the network administrator and ask him nicely and sacrifice a small animal and be really keen. And then he gives you this file printout with a lot of information, numbers in it. And it's cool. It gives you your history, sort of, and all the events, but it's not that usable. And we're trying to make things usable. The first simple way of doing this is to simply represent the events in a log file. We list the events that led up. This comes from a paper review system. And there you can see the review events that caused the paper to be in the state as it is. I have actually used this because my boss changed the paper to reject by clicking on a button accidentally. I could prove that he did it. So, it's useful. Saved me a lot of trouble. The second example, which a lot of people might have seen, is the concept of the Facebook timeline. We also have events, same. Events are listed, in this case in time axis, and you can see them one after the other, the sequence of events that caused the person to be as he is now. In these two cases, you have one of the screen dimensions which is dedicated to the time axis, and the other screen dimension is dedicated to displaying events. But you can also go back in history by simply displaying the objects as they were in the past. The classic example here is Apple's time machine, backup system. And in this case, you have a control where you can manipulate the time there on the side. So the time axis is directly manipulatable by the user. And when it goes back, those things come to the front and shows you the file system as it was at that moment. You don't have a sequence of events. Another more interesting example is the Git comparison editor in Xcode, where you have a file and you can directly compare it to its previous versions. You also have a control here, and again, time is represented as an axis. And, wrong button, sorry. There is a control. You can have two axes. You can have compare two different times with each other. And the two files are listed next to each other. Those two files are the files as they were in the past. And as you can see, this is useful. Now, when it comes to user interaction, users work on a task. They commit a sequence of steps, one after the other, towards a goal. And very often, they tend to perform the same thing on a sequence of objects. Users seldomly take an object, perform a sequence of tasks on it, takes another object, performs a sequence of tasks on it. Very often you have a list of objects, and you perform the same task, A, on all the objects, and then the same task, B, on all the objects, and then the same task, C. The sequence is not per object, the sequence is per task. This is temporal coherence. It means that in close proximity in time, the same things happen. And because you know what the user was doing just now, you can predict what he is going to do in the future. We can use the history to improve the flow. Flow is about momentum. And temporal coherence is something that we can definitely use to improve it. We'll look at 4 examples there. It is very important to help the user go, because if he does small tasks, one after the other, he has to click the open box, make the file, click, click, click here, do the same thing over and over again. This is something that costs a lot of money and wastes a lot of time and causes a lot of frustration. Now, predicting the future is hard. If I was able to predict the future, I would know what the stock price is in 3 weeks, and I wouldn't be talking here. I would be sitting in Tahiti in a bubble bath. So, when we want to know what the user is going to do to help him maintain flow, the only information we have is the past things that he has been doing just now. We also have the state of the system as it is at the moment, which is, unfortunately, what most programs use to predict the future. They don't, they just use a default. An example, who of you have email programs? Lots of everybody's hands up, right? Who of you get spam? Nobody gets spam? Am I the only one who gets invited to a lot of girls in a bubble bath and win the lottery 3 times a week? I don't know. Maybe I'm just lucky. I should answer my spam, then I wouldn't be sitting here either. So, I'm a nice guy, so I don't go for the girls in the bubble bath or the lottery, and I delete my spam. Keeps my wife happy. Now, the easiest way that you usually see is people click on the mouse and delete. Click with the mouse, press delete. That frustrates me. The faster way is to use the older keyboard, arrow keys, and you go up and down, click on mail, click delete, click on mail, click delete, click, 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 look through the mail, click delete. It's a simple thing. Okay? You move through the mails with the arrow key and you delete them as part of a review of your spam folder. Now, second example. Here is a list of 5 items. Currently, we're at item 3, and we want to sift through them and delete some of them. Now, I'm going through this list with a down arrow today. I go the down arrow, I was on item 3, click the down arrow, now I'm item 4. This is a spam. This is a lottery win. No, from Nigeria or somewhere. I'm from South Africa, so get that too. Now, I don't like it, press delete. Now, I had a list before, and now I removed one of the items. And the item I removed was the item I had selected before I pressed the delete key. Which item should be selected now? It's a good question. It could be either 3 or 5, because they are both in close proximity to the item where I was. But it's not obvious what you should pick. Most programs have some algorithmic default, which often is the next thing in the logical list, regardless of which direction you have been moving in. They just pick, if you delete 4, the next item, which is 5. Great, okay, so we deleted 5. Now, I was moving down the list. Remember, I was at 3. Deleted 3. Now I'm on, well, I should be at 4, actually. Oh, sorry about that. No, I moved down and deleted 4, and now item 5 should be deleted because I'm in that direction. Item 5 is there, so if it's a spam, I can delete it. This is a natural flow of events. I click and click and click and click, delete, click, 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 delete. My click commands, it's a micro interaction, a very small interaction, but it has a direction. If I press the down arrow the whole time, I'm moving downwards through the list. And the software should really take that into consideration. Now I deleted the item, and now I'm automatically on item 6, which is the item I would have selected if I had pressed the down arrow again. It keeps my flow. Now, let's start again. We're on item 3. I click the up arrow this time. Sometimes I do that. I look at my mails and click some arrow and go through them and delete them. This is a problem that frustrates me because Apple Mail doesn't do this right. And I have deleted mails that I shouldn't have deleted. So, we deleted. Item 2 is a spam. Delete it. Now the algorithm is the same, and it selects, like before, the next thing in the mail, the next item in the list, which is 3. But this is the item I just came from. This is not what I want to delete in the next step. The correct thing to do would be to select item 1. This is a small, little, tiny micro interaction, where using the past and the direction where you were going, and maintaining a flow and maintaining momentum and seeing where the user wanted to go and using past actions to try to predict the future of where he wants to be makes a difference in the usability, a big difference. And one should never forget that all of the systems we write consists of small micro interactions. Getting those things right is important into getting a system usable. Let's keep the flow going. Determine the direction. Remember the past and use it to predict the future. Micro interactions that are done bad are like stumbling blocks. You trip over them. And this is something that frustrates users. Another example, file open dialog box. This one we know. This is something that Microsoft only got right in Office 2003, I think. No, 2007. 2003 is still later on. If I open a file, I don't want to start in Documents. I want to start where I last opened the file, because usually we have temporal coherence. The files I work on are in the same folder. I click on a file, open it, edit it, then I open it again, and then it takes me somewhere else. Office had forgotten where I was. It should take the past into consideration to predict heuristically what I want to do now, where I want to start. There are still programs, I won't name names, Adobe Distiller, which does this. When you save the file, it always opens a dialog box on the same place. No, I don't want to save the file there. Please remember where I wanted to save the file. It's not brain surgery. Other software systems got this right in 1985. This is 30 years later. Another small example, disclosure boxes. This comes from a review system as well. A user selects a document and has a set of things that he can watch. He can open detailed disclosure boxes. Can open the notes to for instance, and we can see it. And often when people are performing a task, they are interested in the same details of the documents they are scanning through. You have a document, click on it, you want to see the notes, you scan through the list to see all the notes. Classic case. Sometimes you want to edit the addresses. A good heuristic is to assume that when he opens another document, that the same thing should be open. Again, we are using the immediate past of what the user was doing to make a prediction of what information he wants now. Predictions of lists shouldn't damage things. It should just be a heuristic, a basic simple guess, but it very often makes a big difference in the usability of a system. He selects a new document. We must make sure that the same view is open. Again, micro interaction. Small, tiny, little, inconsequential, you think, detail. Big difference. It's like a little stone in the ground where you can break your neck on. Sometimes, however, we know beforehand where we want to go. It's not like we don't have an idea of the future. We have a system in a business process. A business process is a sequence of tasks that we know that when they're finished with this set of tasks, we need to perform those tasks. Go from A to B. If we know what the future is supposed to look like, we can use that to guide the user. I know that here that I'm in state in the middle, and then I have to go to some next state. There are some steps that I need to perform next. The software system knows this because this is predetermined. We do not need to guess the future. We know it beforehand sometimes. If we do this, we can use our user interface and put something in them to guide them there, to help them achieve their task, because we know what the next step is. Again, we use knowledge of the history of the object that we're manipulating in the user interface to maintain flow. Take-home point number 6. Assume that the user might be doing in the immediate past what he was doing in the immediate future, what he was doing in the immediate past. It's usually a good assumption to assume temporal coherence in what users are doing. You can maintain the flow by predicting or knowing the future. If you do this, you make the flow better. There's inevitability of moving from A to B through a software system. So, the object model. Okay. Now, back to this. It's slower to transfer 1 megabyte of data between this and the hard disk, the floppy disk it was plugged into, than it is to transfer 10 megabytes around the world today. Let me repeat that again. Today, it is faster to transfer 10 megabytes around the world, 40,000 kilometers, than it was in the days of these things to transfer a megabyte to this over a distance of 5 centimeters. So things have improved in terms of speed. Now, right now, this is a ubiquitous thing in user interface. It's called the file dialog, the file menu. It has a load and a save button. This comes from, I think, the 1970s at Xerox. And it's old. It's present in basically every piece of software you know. And the question is if this is really what we want to do. What does the file save button do? What happens if you save a document? And why do programs have a save button and a load button? Now there is another icon for the save button, which describes it. It's a good question to design if this, my child would definitely not recognize this icon if she sees a program. I recognize the icon because I have used these things. I seriously don't think my daughter would ever use a floppy disk, unless she's in a museum. But the icon's still there. I see lots of software with floppy disks and an arrow on the download. Why? The problem is that the load and save commands that are ubiquitous in software are the product of a very archaic storage technology which dates back 30 years. And the question is if this is really what we want now in the future and in the present. Classic object lifecycle. We have a computer with a hard disk and main memory. On the hard disk resides a set of objects, documents, and we want to work with them. So we open the program, press the load button, there it goes into memory, and now we edit it. Now we work on the software. Blah, 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 blah type, and when we're finished, we go to that file menu we saw and click save, and it goes back to the hard disk. Okay, fair enough. Why do we do this? The other thing is that the only part in the program's object lifecycle where we can examine the history of what we were doing is the undo stack. I can open a file in an editor, say a text editor. I can edit things and say, that's wrong, undo, Steuerung Z, my favorite key. And it goes back, and then I press Steuerung Alt Z, it can go up again. If I go back and I type something, the entire undo stack from that point upwards is gone. This is a shame, because sometimes I just wanted to go back, what was I doing? And then I press something and so I often copy a file entirely before I do a lot of undos just to see what I was doing and where I was going. And the moment I save the file and close the application, the history is gone. It's only kept in the main memory, the part upstairs. It's never kept in permanent storage, seldomly. The thing is, computers have changed over time. But current UI paradigms, the things that we do on a day-to-day basis, are still mired in the past. Maybe in this case, we don't want to deal with history. We want to forget about it, start over again, or at least move into the present. In the old days, we saw a lot of those things, a blue screen of death. Anybody ever see that? Yeah. Now, dead honest, seriously. How often have you seen a blue screen of death in the last 5 years? Seriously. I'm not talking about people who develop kernel drivers. Okay, that's an exception. Not very often. I mean, I crash my Mac more than I crash a Windows system, I have to admit sometimes. But screen computers have become way, way, way more reliable. In the old days, they had a save button because that machine that had your work for the last hours could just vanish into thin air. And boom, blue screen of death. But I didn't save for the last hours. I was a system administrator for many years. This is the main reason you have backups. You don't have backups because of a fire in the cellar and because a lightning bolt destroys all your server. You have backups because users delete their files and they didn't copy them. This is 99% of the time what the problem is. But everybody always worries about taking the tapes out. Forget about it. Nobody's going to burn down your building. In the old days, we used to have these things. They are slow. Slow. Like I said, it's faster to transfer data, 10 times the amount of data around the world than to copy things to this thing. But our paradigm is still built around this. The concept that you have a memory hierarchy. You have a main memory in your RAM, then you have a hard disk, which is slow, but is permanent. Or you have backup, like optical or tape, or some strange magneto-optical disks, which people send you for documents. I don't know. I've gotten that. Disks that are only used in Japan. Thanks. And the load and save command is really based on the idea of manually, by hand, taking a decision to move things between memory banks. You have it in your main memory, then I press the save button. I took a decision to shift my document from A to B. It's like a shubkara, what is that? A wheelbarrow. I put it in there, and then I slap it there, and then I go and fetch it again and slap it back to the point where I was. And this has a lot to do with the way computers worked 30 years ago. Nowadays, the very concept of shifting data around is a bit hazy because a lot of the software doing is not even on your machine, it's in the cloud, somewhere up there. That's supposed to be a cloud, by the way. I'm not an artist, I'm just a presenter. Well, it's blue at least. I don't know why people paint clouds blue. They're supposed to be white, the sky is blue. But anyway, so that's a cloud. So this archaic notion of shifting documents between somewhere and somewhere is very hazy because we're not actually having the document on our computer. If you log onto Google Docs, that spreadsheet that you're editing isn't really here. It's really somewhere out there on a server. And there's still a save button. But the save button has another function now. The save button commits the changes that you made. It's not an explicit command to transfer the data. It is an explicit order to say, this is the version in history that I want to be current. You are not manipulating the data. You are manipulating the history of the thing that you're editing. Lots of software, most software nowadays, still don't deal with that. But the whole notion of saving and loading is something that doesn't make much sense anymore. So what do we need? There is a serious impedance mismatch between current paradigms of user interfaces and the reality of current technology. Classic document transfer is becoming obsolete, and we should look at new ways of dealing with this. Now, Saving should not transfer data between memories. A save command, like in Google Docs, should be a checkpoint in history. And we need actions in our software to manage the history of the objects that we have now. We are not working with a document anymore. We're just working with something that existed in the past, had changes, and exists in the state it is now. And this is what the save button really does now. It just commits us to a point in time. But the entire sequence of events still exists somewhere, or should. Perhaps we should also be able to do alternate histories. Version control system. Who has ever worked with Git? Hands up. Lots of people. That's good. So you know the concept of branching and merging. This is really useful. It might also be useful in other programs. The fundamental problem there is that it's hard to do a merge in a non-text file. Git can merge text files pretty well. But as soon as you're dealing with an XML file which has a structure, anything with a hierarchical structure, XML, JSON, merging becomes a problem. Because the sequence of things do matter then. Or sometimes they don't. And then you need more information about the document structures that you're dealing with to merge. But it might be useful. Imagine in Word you could split the document, make some changes and see what somebody else did and merge them back again. Might be useful. It can sort of do that, but not quite. It's not as good as Git. But this is what we want. Now, when we are manipulating the history of the object that we're dealing with, it's a good question at what granularity we're working at. Should we have save points? In Google Docs, for instance, if I press save, I have a save point. In Git, if I do it add now dot and I commit, I have a point that I committed, an explicit decision. Another option is to keep a history of each action that I perform. We'll look at an example in Photoshop just afterwards, which does that. Or I know about the text editor. I forgot the name of it. It was available in the 90s, where there was a text editor which remembered every keystroke you ever typed. And it saved the entire undo stack forever. There was no save command. You open a text file and you just edited it, and it was always saved. The thing always tried to thing, and you could undo the things you did 5 years ago. Because in a hidden file, it saved the history of the file. This is actually useful. There are 3 examples that we can look at for things, software systems that allow you to manipulate history. The first is version control systems like Git. I saw a lot of hands there, so you know that. In Git, you can have a set of steps and explicitly commit them, one after the other. And you can also have an alternate history. You can branch. And somebody else could do this, or you could implement a feature that runs in parallel, and then in the end you merge it. Now, version control systems always work, well, usually works, with a system that has a set of text files. And this is what gets merged, and this is what gets manipulated. If you use a document editor like a spreadsheet, we have a grid. Or Word, where you have an hierarchical document, or LaTeX, whatever. Or an XML file, a JSON file, we have a hierarchy. That merge operation is not so trivial anymore. The diff operation either. Because if you have a list of things, suppose somebody switched 2 things in the list, the system that merges or diffs, which is the core of Git, has to have a little bit more knowledge of what you're working with, and that's missing in version control. So it's not that usable for general purpose software at the moment, but it might be something to look at. Anybody here wants to do a PhD in that? Make a lot of people happy. An interesting example is of a system that does this part of the second one there. Each action saves a history point at each action is Photoshop, which has something called a history brush. I can take an image in Photoshop and then run desaturate on it, which is there, the second thing. Photoshop remembers the phase that it was at open. Then I do desaturate, and the thing becomes black and white, but it still has a history of how the thing was. And then it has a tool that you can use, a pass point in the history as a brush. This is often used, take a black and white picture and just bring in the face. You see this a lot with pictures of flowers. That's my daughter. And this was a color picture this morning. So I went back, desaturated it, and used the history brush to paint over a face. The thing used the state of the object as it was in the past and applied it to the state as it now, and created a new state called history brush. Could have called it something else. We can also do this with pictures of dinosaurs. So, that was a challenge I made. But it's the same idea. You have a picture, change it. This is a useful feature where the system automatically checkpoints. You don't have to do that explicitly. You can delete history items because they use up a lot of memory. But Photoshop makes a history point every time you perform an action, and you can use the history in what you're doing now. You can also go back and look at what you were doing. My dream is a text editor with eternal undo, like I said. And one thing that really annoys me in every text editor, TextMate, Sublime, there's a lot of them. You have multiple tabs. I work on the file, then I close the tab, and then the undo stack is gone. Thanks, can I keep it, please? I would love that. Because if I accidentally close the tab and press Alt-Shift-T to bring the tab back, I would like to be able to undo what I did. But no, it's gone. I would be happy if it saves all the changes I did. Then I wouldn't need Git, because all the changes in the file would always be there. Well, so it brings us to take home point number 8. Manually moving data is the past. Directly manipulating history is the future. Manually moving data is due to a very, very old paradigm. You really don't need to do that anymore. Now, amnesia. Oh, I forgot what I wanted to say. No, wait. Oh, yeah. Why would we want to forget parts of history? Well, the internet has this habit of remembering everything that you pass onto it. There are things like the Wayback Machine that sucks up websites and keeps a history of them. And sometimes there are things that you wrote on the internet, or pictures, or stuff, or documents that some hacker posted somewhere, or whatever, that you don't want there. So sometimes you want the user to be able to delete history. This is important. Privacy issues. Confidential information that was part of your history that nobody wants to see or isn't relevant anymore. Data that's not needed anymore. For instance, tax returns from the 1970s. Not even the Finansamt is interested in that. You only have to keep these things for 10 years, but sometimes they get archived forever somewhere for some reason. That saved game that you had on your file, that you were meaning to replay, which you were playing 15 years ago, I have some of those. You can delete that, really. And sometimes your disk actually does get full, even in the modern age. But yeah, that's not often the case, as we will see later. Another thing, this has to do with specific documents that we want to forget. But things that are automatically created in a software system that maintains history, this is a good question. Suppose we have an undo stack that lasts forever. How long should I keep it? Suppose I have a text editor that keeps my undos in my tabs. Should the text editor keep the undo stack forever? Should it keep it for a day, for a week? What makes sense? That's a good question. One should think about that. Test data. Whenever I develop a system, there's always some test users in it and some test papers that runs through the system. Do we want that in the backups and in the history? No. Then delete it. A good question. Take on point number 9. Check how long and what you want to remember. Sometimes forgetting makes sense too. So why would we not want to do this? Now, the first issue that always comes up when I say I want to save the history is storage cost. At the company I work at, we do confidence management systems, and what I do is I checkpoint the database, which is in Postgres, into a Git repository every hour, forever, as a backup. All the data of all the conferences we did in the last 10 years takes up about 200 megabytes of space. It's a joke. Storage cost is not an issue. There is no reason. User inertia, we'll look at that. And then sometimes you have to remember that the maintaining history causes implementation and user interface complexity, which is not necessarily good. Now, as far as storage space is concerned, that is the price of hard disks over the last 3 years. That's a logarithmic scale, it's not linear. In 1981, Creative Computing magazine stated that the cost of 128 kilobytes of RAM will be dropping to $100 in the near future. Right, very funny. When I was a kid, many, many years ago, I had a box of floppy disks, not these, the slightly smaller ones. And my mom came past to pick them up to drive them to my father and forgot them in the car's sun on the dashboard. Now, that was half of my income for a month. I was a poor student. And the disks were melted. They were destroyed. I wasn't even worried about the data. I was worried about the disks because they were expensive. Buying a box of disks, which contained 1.2 megabytes each, which is 12 megabytes in total, was a serious investment for me as a student. Not anymore. This machine has a terabyte of SSD on board, never mind floppy disks. It doesn't have a drive. It doesn't have any external storage. This is the future. the cost of memory is going down. It has been falling faster than Moore's law has increased speed of computers. And 2-3 years ago, the price of hard disks was falling by about 15% a week at the time. 15% a week was the price of bit falling. It is amazing. If you look at this graph, by the way, there's a small bump there at the end. That is a jump caused by SSDs. Solid state disks. They're more expensive than magnetic storage. But they have other trade-offs. And as you can see in the global picture, it's a little blip. It doesn't matter. In 2 years, 5 years, nobody's going to use magnetic hard disks anymore. Now, there's this issue of user inertia. We have been using the file save dialog box for 20 years. Users like it. They know it. They've been doing it for 20 years. And now, there's something new. No, we don't want that. Apple tried this. In the newer versions of Mac OS X, there's no save as document. You have another system. It automatically versions your documents, which is what I said, good. And you have an option of duplicating the document. But there's no save as command on the menu anymore. And there was an uproar. People don't like this. And blah, 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 big freaking deal. There's a lot of user inertia. It would take a lot of effort to change the way we do things. And there's a lot of complexity involved in storing history, which is not something one should forget. One small problem that when you're storing history and you store it with differences, suppose we have one version and we only store the difference to the next version and no other difference to the next version, has two effects when you maintain the history. If you make a delete in the difference, you have to maintain the delete throughout the entire history. If you delete something then. This is why it's not possible to delete a file in a Git repository in the past. You can't delete it. It's gone. It's there forever. Because you would have to, Git saves only the differences between the files. If you delete the file or make a change, you would have to save that difference through the entire repository. Not going to happen. If there's an error in the repo, and you only maintain the differences, then everything is damaged from that point onwards. This is a complexity factor that we would have to take into consideration in system implementation, is that maintaining a history could have an impact on your reliability. Take home point, the last one. Lack of storage is not an excuse. And sometimes the users don't like it. Often they don't like it. They don't like nothing. How would we implement things? The world would be so much better without customers and users. But somebody has to pay the bills. I don't want to work all day, but the bank says pay, 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 and I have to get the money somewhere. So, implementation. When we want to save a history, we can either store snapshots of the entire object over time. Tick, 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 tick. We can store the events that created the objects up to now, or we can store the differences between the snapshots, which is what the version control system does. Just like the file save dialog box, which has to do with transfer of data, is reflected directly by the technological realities. If you implement a history in different ways like that, it will probably reflect into the user interface somehow. Git, for instance, has a user interface that's very often based on diffs. You send a patch to somebody. This is because Git thinks in terms of diffs. The user model and the data model of Git is in terms of differentials between things. If I make a change and I want to send it to an admin, I send him a patch. And the back end of databases, we can also save this as a logging. One database that's an interesting thing to look at is a database for Clojure, which is a Lisp that runs on Java called Datomic. Datomic maintains an entire history of all the data that it always has ever had in. There is also actually a version of SQL that allows you to go into the past. It's called temporal SQL. It's not very commonly implemented, but you can do queries like select stern from somebody, from some record, as it was then, and it will give you the data as it was at the specific time. There is a standard for that. Or you can do in the backend snapshotting with distributed version control systems, like Git. I do this with backups of databases. So, in summary, the 10 points. Point number 1, the userverse consists of processes, not things. If you want to write down, now it's good. You can leave the rest of the slides. Users, action, software, objects are the results of a process. This is not about construction steps. Often, going to the history is about why the things they are the way they are now. We're not actually interested in how they are. We are interested in why they are now, how it is now. Point number 4, we want to maintain flow. Flow is good. Flow is about momentum. Flow is about change over time. We can use the history to maintain flow. The database state is just a cached version of the event log. Assume that the user might be doing in the immediate future what he was doing in the immediate past. Good way of predicting the future. It's unfortunately not a good way to predict the stock market. Maintain flow by predicting or knowing the future. Manually moving data is the past. Managing history is where we're going. And check how long and what you want to remember, and sometimes you want to forget stuff. And lack of storage is not an excuse, because the price is dropping very fast. Thank you, that's all from me. Any questions? Sorry, I went about 2 minutes over time. So. Yeah.
Hi.
Hi.
Thank you, that was very inspiring. I have a question. You said managing the history is the future, rather than manually moving data around. And you also mentioned that the implementation of how things are persisted will have effects on the user interface.
Yeah.
Like in the implementation, you mentioned storing snapshots, storing events, and storing diffs.
Mm-hmm.
I think I agree. I mean, I think this is a really important topic, this managing the history from a user point of perspective. Do you have like recommendations of UIs to look at that sort of show the future of how to do this? History?
I think the system that is pretty much the most important one as far as manipulating history right now is Git. And there are a couple of GUIs there that you could look at. But like I said, the problem with Git is that all of these DBCSs are running on a set of files in a file system. And they don't work with a single structured document, which is a problem. The sort of actions that you have in Git, that you have a commit, or in Bazaar, or in Mercurial, they have slightly different implementation paradigms and user way of thinking about this. This is something that I would look at primarily. Another thing that's interesting, look at this Photoshop's history brush. That's a quite useful feature sometimes. But Git is where the action is at the moment, I would suspect, or visual control systems in general. One more question? Okay, oh, there's one.
You talked about time and the importance of time in the real world, and that we model it in digital systems. And I was curious why you made no suggestion that to represent time directly. What about using movie-like ways to view the history with fast forward and so on, like we do with video or so? This would be a more intuitive way. Could there be some developments in the future that would more directly represent time in UX?
Yeah, I can actually give you an example of that. That's a good point. Yes, I would agree. Just a second. There is a program that does this for Git, in fact. It's called GURS. This is an actual real-life Git repo. Wait, I just have to slap it onto the demo. And that's what happened in the Git repository over time. That is a valid point. Yeah, it's something that I could put in the representation. You want to entertain yourselves for half a day and waste? Download that thing and run it on a Git repo. It's really cool. In the beginning, I worked on the repo alone. It was a few years ago. But then when there are multiple programmers who come in later, they all flitz around and flash around and modify files. It's pretty cool. But that's a very valid point. Yeah, you could directly use it as an animation. I must take note of that. Thanks. Any more questions? No, we don't. You can entertain yourself forever with that program. So download it. It's open source. It's called GURS. It also works with Mercurial. Thank you.
Thank you, everyone.